All right, good people, here we go. The second derivative test. And I'm going to add something here. I'm going to ask you to, I guess, save it in your brain. The second derivative test for relative extrema. We're still looking for relative minimums and maximums. This is the second derivative test for relative extrema, just like we had the first derivative test for relative extrema. So consider a function where f prime of c is equal to 0. So we have to start with a critical point. So if I know that c is a critical point, then if the second derivative is positive, that's what this means. If it's positive, excuse me, that means it's concave up. And if it's concave up, then f of x has a local minimum at x equals c by the second derivative test. Or if the second derivative is less than 0, that means the second derivative is negative. That means it's concave down. That means I have a local maximum at x equals c by the second derivative test. However, if the second derivative is equal to 0, or the second derivative is undefined, then the second derivative is inconclusive. I don't have enough information to figure it out, and we cannot apply it. So f of x may have a local minimum, maximum, or neither at x equals c. So now we got to go back to the first derivative and see if we can do that. So some people think that or consider the second derivative test for relative extrema to be a shortcut because you find the critical points just like you do in the first derivative test. But instead of making a sign chart, you take the second derivative and then plug those critical points into the second derivative to determine what kind of concavity I have. And it is shorter. It could be a lot shorter than the first derivative test. However, be aware that just like the first derivative test sometimes cannot be applied, the second derivative test cannot be applied if the second derivative value equals 0. It's inconclusive. If the second derivative is undefined, it's inconclusive. That doesn't mean that there is no local min or local max. It means that I can't prove it by the second derivative test. Again, second derivative test is for relative extrema. We're looking for relative mins and max, local minimums and maximums, not points of inflection. This is not about finding concavity. We use the second derivative to find concavity. We don't use critical points in the second derivative to find concavity. We use them to find relative extrema. So just to make sure we understand, side by side here, both the first and the second derivative test find relative extrema, find relative minimums and relative maximums, local minimums and local maximums. That's what they do. And as a matter of fact, the first step on both is to find where the first derivative is equal to 0 or undefined. Finding the critical values is the first step in both tests. But when I do the first derivative test, I use a sign chart, and then I consider the first derivative changes in sign from positive to negative or negative to positive. But in the second derivative test, I take the critical values and I plug them into the second derivative, and using concavity, I'm able to figure out whether I have a relative minimum or relative maximum. So when do I use each? Well, it depends. Most cases, whenever we have to find x values where f of x has local extrema, we're going to use the first derivative test. If they give you an equation, chances are you can take the first derivative, you can use the first derivative test. Easy. However, there are two places on AP exam where you might be required to use a second derivative test. The first one is if you have a table of values. So in other words, if you don't have an equation and all they give you is a table of values, you might have to use a second derivative test. Not that you have to, but you might have to, right? And then the second case where you might have to use the second derivative test is an implicit relation or an implicit curve. What that means is my equation is an implicit equation. So something that looks like, for example, something that looks like this, where remember we combine x's and y's. This is an implicit equation. It's not solved for y. It's just mixture of x's and y's. I might have to use a second derivative test for that. That's the big idea that we're going to practice in the next video. As we get into the next one, we see a table, and we'll be able to use that to figure out where the relative extrema are.